Hello everyone. Welcome again to yet another interesting and essential topic. In week 4, unit 3, we will learn about different monitoring options for the cloud integration capability of SAP Integration Suite and how you can effectively operate a cloud integration tenant and integration scenarios. Monitoring is essential for ensuring the smooth and reliable operations of integration processes within a cloud-based environment. It plays a crucial role in every heterogeneous landscape, particularly when an integration middleware is in place. The cloud integration provides various built-in monitoring functionalities in the standing monitoring dashboard that caters to the need of integration developers and technical users. However, these monitoring options are often perceived as technical and may have limited relevance for business users who prioritize functional aspects and end-to-end monitoring. To bridge the gap and cater to the diverse needs of various users and use cases, SAP offers multiple monitoring possibilities like centralized monitoring and alerting using SAP Cloud ALM, archiving data to a customer owned archiving system, logging monitoring data to an external persistent solutions, etc. We will learn about all these options in detail in the subsequent slides. The standard monitoring dashboard of cloud integration provides essential monitoring features using which you can monitor messages and integration artifacts at runtime. The monitoring tab consists of various sections and each section contains tiles which show filter settings and the number of messages or artifacts that correspond to the filter settings. The tiles in the monitor message processing section shows the number and status of processed messages within a specific time windows, allowing users to view details of individual messages. The Manage Integration Content section provides information on deployed integration artifacts, including their deployment status and corresponding endpoints. Security section allows you to manage certain tasks related to the setup of secure connections between your tenant and remote systems, whereas Manage Stores monitor temporary data storages like data stores, variables, queues, and number range objects. Access Logs provides access to the system log files and analyze errors that occur during inbound HTTP processing. Finally, in Manage Logs, you can manage message log as well as design time artifact log entries. The standard monitoring dashboard also provides enhanced filtering options for process messages in addition to the standard filters. The standard filter options in cloud integration monitoring includes time, status, and artifact IDs. Additionally, users can also set additional filter criteria using additional properties that can be written to message processing logs at runtime using a content modifier step. By this, the integration developer can add business context to the logs. These fields include sender, receiver, custom status, application message ID, and application message type. These filters allow users to narrow down their search and focus on specific messages. Moreover, users can utilize a script step to set custom header properties, which are name value pairs. This allows the inclusion of business or payload related information in the message processing log to search messages based on a specific business context. Certain industries and jurisdictions have regulations that mandate the storage of specific data for extended duration like 7 years, whereas cloud integration monitoring data are typically stored for 30 days. For such use cases, cloud integration archiving feature can be used. The archiving feature allows customers to store messages processing logs in a customer-owned archiving system such as Content Management System, also known as CMS. The external archiving system must support the CMIS API standard version 1.1. To use the archiving feature, you need to configure a destination to your archiving system, activate archiving on the tenant using the Activate Archiving configuration on OData API, and finally, enable configuration of the archiving settings in the user interface. You can archive data for persist step content, adapter payloads, and attachments. The system job also records specific key performance indicators (KPIs) of the archiving runs. You can use these indicators, for example, to check for recurring errors or potential performance problems. You can use the official OData API to query the KPIs. SAP Cloud Application Lifecycle Management, also known as SAP Cloud ALM, is a comprehensive solution that provides central end-to-end business and IT monitoring for hybrid SAP-centric landscapes that bring the technical flow closer to the business context. SAP Cloud ALM offers integration and exception monitoring for integration scenarios, ensuring end-to-end visibility across different systems. It enables the correlation of messages, providing a holistic view of the data flow. It also provides the capability to report failed messages and deployment exceptions. Users can also track messages based on business attributes with automated alerting for proactive monitoring. Additionally, SAP Cloud ALM enables context-sensitive jumps in to standard monitoring tools, streamlining issue resolution. Technical health monitoring capabilities of SAP Cloud ALM track the overall cloud integration tenant health based on the JMS resources and validity of the certificates and key pairs, with the possibility to customize the metric threshold as well. In addition to the built-in standard monitoring features of cloud integration, there may be scenarios where you require external logging capabilities to further enhance your monitoring and troubleshooting processes. External logging allows customers to push message processing logs in real time to external customer-owned persistent solutions like Splunk, regardless of database storage availability. By capturing and analyzing log data in an external logging system, you can meet compliance requirements, use it for high throughput scenarios and high volume queries, which are currently limited by our systems and databases. And it is also suitable for central observability by consolidating logs of multiple tenants and possibility to create advanced analytics dashboards. To activate external logging on your cloud integration tenant, you will need to follow a few simple steps. First, set up Splunk as your designated external logging destination. As a tenant admin with the role external logging.activate, you have the necessary permissions to proceed. Then, utilize the activate external logging function available in the official OData API to initiate the activation process. The log label for integration flows can be independently configured for both standard monitoring and the external logging system. The OData APIs of SAP Cloud Integration provide a set of standardized interfaces that allow developers to interact with and manage various aspects of the integration platform programmatically. These OData APIs are documented on SAP Business Accelerator Hub and provide a powerful and flexible way to interact with SAP Cloud Integration, enabling developers to build custom integrations, automate processes, and extend the capabilities of the platform. It provides a wide range of operations, and using this, you can achieve multiple use cases like customized monitoring, alerting on failed integrations or expiring keys, notification of high JMS resource usage, CI/CD pipelines, etc. The topic CI/CD and DevOps in general is very important when you want to create or maintain integration content, be it integration artifacts on cloud integration or API proxies and other elements on API management. Due to variations in landscape and processes among customers, the CI/CD pipelines may also vary. Rather than endorsing a single approach, our focus is on enabling multiple methods to implement DevOps. The most simple and crude way is to use the OData APIs for cloud integration and API management that are available on SAP Business Accelerator Hub. We do also provide ready-to-use pipelines for Jenkins Git infrastructure to accommodate individuals who may not be familiar or comfortable with scripting. We provide pre-built scripts that require minimal configuration changes for your environment. Our pipelines serve as valuable examples for experts to extend or modify as needed. You can access these resources through the SAP Business Accelerator Hub community. Alongside the pre-built pipeline scripts, We have made contributions to the Piper library by adding commands for cloud integration and API management capabilities. SAP Continuous Integration and Delivery, a low-code, no-code service on SAP BTP, also provides a predefined pipeline for SAP Integration Suite. SAP provides tooling for CI/CD via Project Piper to simplify and streamline the setup and execution of CI/CD pipelines. It focuses on promoting best practices and reducing the complexity associated with setting up CI/CD pipelines. As I mentioned earlier, the cloud integration and API management capabilities of SAP Integration Suite offers many Piper steps leveraging the underlying OData APIs. The delayed software update feature of cloud integration provides a self-service option that allows a 1-week delay in production tenant updates and increments, effectively mitigating regression risk for custom integration flows. By delaying the software update in the production tenant and consuming the regular update in the test tenant, organizations can ensure a smooth transition and minimize disruptions. Tenant admin can enable this in their productive tenants by navigating to the Integrations Settings tab. It is important to note that this delay is applicable only for monthly increments and specifically for cloud integration runtime only. To facilitate easy comparison of versions between test and production tenants, the About dialog in the tenant displays the cloud integration runtime version. Now, let's jump into the demo where we see how you can activate the delay software update feature, and then we also create a CI/CD Jenkins pipeline using the Piper commands for cloud integration. I'm in the landing page of SAP Integration Suite. Let's navigate to Integration Settings tab. There you see a Software Updates tab. Just click on Edit and just toggle the Delay Software Update to enable the delay software in your productive tenants and save it. Now we are into another tenant where this setting has been enabled. And in this productive tenant, you can see it also shows you the next date when this tenant would be updated. And in the About dialog, you can also now see the cloud integration runtime and the design time different versions, as this is only applicable for cloud integration runtime. So you see this is on a lower version than the cloud integration design time. And it also shows you the date on which this would be updated. Now, if we see a test tenant where this settings has not been enabled, see if you can see here the settings has not been enabled. And if I go to the About dialog, I should see both the cloud integration design time and the runtime versions are same. Now we will see how we can quickly execute a CI/CD pipeline for cloud integration using the Piper command. I am on the Project Piper landing page. You can see the library steps related to API management like API proxy list, API provider download, and the library steps for integration, cloud integration. And there's also a detailed blog post from my colleague Mayur where you can also learn how you can quickly create a CI/CD pipeline using these Piper commands. So I am into a GitHub where I have already configured a Jenkins file. This is a Groovy script where I have defined the stages, and what this will do, it just utilize 3 Piper commands for cloud integration. One is to upload the integration flow from this Git to the tenant. Second, it will deploy, and then it checks the MPL status. And this is the sample flow which it will upload. And this is a config.yaml file where for each library steps we have defined the attributes like the credential ID, the iFlow ID, the package ID, and this credential is already created in the Jenkins server. So see, there is a package ID CI/CD. So in this target system, there is no package as such. So let me create quickly a package CI/CD. I put all the details, name, description, version, vendor, just save it. So now let's go to the Jenkins server. I create a new pipeline, just give a name, open SAP Piper demo, and just create of type pipeline. Again, provide the description. And as you have seen, right, we have created a Jenkins pipeline on source code management. So I use pipeline script from SCM and it is specifically Git. I provide the Git repository URL, the branch name, and that's all. So now, if you see here, So I'm going to the monitoring page, where if you see we have not deployed this. Now I'll trigger this pipeline, and as you remember, it will upload from the Git to the integration suite tenant, cloud integration specifically, and then deploy and run. See, this got completed, and the MPL status is also completed. And if you see in the monitoring, see this iFlow got completed, and this is a completed state. In summary, remember that cloud integration offers a range of possibilities when it comes to monitoring. SAP Cloud ALM enables end-to-end integration monitoring, provides alerting capabilities and tracking of messages using business attributes. It also tracks the overall health of the cloud integration tenants. External logging allows you to push cloud integration logs to your own external persistent solutions like Splunk. This enhances your observability and analysis capabilities. To embrace a DevOps approach with SAP Integration Suite, you can leverage pipeline scripts or explore Project Piper to kickstart your automation journey. Additionally, if you need more control over your production updates, you have the flexibility to delay them by a week through a convenient self-service option. And that concludes this session, empowering you with valuable insights on how you can effectively monitor and operate your integration scenarios. Thank you for watching. Have a great day ahead.